So when we talk about margin of error, yesterday our activity when we were looking at, everyone rolling dice, or rolling a die, I should say, and the difference of, not everyone got the same results. As we worked towards getting, the mean of all of those results, not everybody's mean, became as centralized as everyone else's. Goes along with the idea of margin of error here. Okay, so, and we'll get to specifically margin of error later on in the lesson, but right now we're going to kind of just talk about first of all, some of our population parameters. So in this situation, we're going to talk about estimating a population parameter. So if you're given some survey results or whatever, how you can estimate the results. So in this first example, Seth selects a random sample of students from a local college. He asks students their year in college and how far their college is from their home in miles. So you see Seth's data here, each student listed, whether they are a freshman, sophomore, junior, or senior, and then the number representing their miles from home. First question to go along with this example. How can Seth's sample estimate the proportion of freshmen in the population? Thoughts of what we could do here? Got this sample of information representing some bigger population. How can we use Seth's sample to estimate the proportion of freshmen?
We can add up all the freshmen and then divide them by the number in the thing. And then we add up the whole population and divide it by the whole. Find 2 beats.
Okay. Well, and we don't have the information for the whole population, but we do have information for a sample, right? And this sample represents the entire population. Okay. So the fact of, can we count up freshmen here? Can we count up how many people Seth has data from? Okay. And use that to estimate the proportion of freshmen. Okay. So the idea of you estimate the sample, and that sample represents the population. Now, depending on how he surveyed people will depend on how well it represents. Okay, if he truly got a random sample, then this should be a good representation. Okay, so with that in mind, what do you have here? Did you count freshmen? We see 4. Okay. And how many people did he survey? Or how many students did he survey? $20. Okay. So, and I was going to write a description, but yeah, so we're looking at the idea of 4 out of 20. Okay, so one option is a fraction. What do we know about 4 out of 20 as a fraction? Simplifies to 2 over 10, which continues on to 1 over 5, right? Okay. Depending on the problem will depend on how they want you to answer. What is this as a decimal? Okay, 0.2. What is this as a percent? Okay, and that's just going to depend on, where you're at in this chapter, how they want you to express information. But the idea here that what we do, we took the proportion of freshmen in the sample and as an estimate of the population. So I'm just going to write a note here that to find proportion of freshmen in sample to represent population. I need more tissue. issues. Okay. And so ultimately, here's your answer. But I wanted to give a little bit of information of, okay, you know, how did we do that? Now, write down what you need there, and then start thinking about the second question. The second piece is asking us, how accurate is the estimate likely to be? Okay. What are the things that will determine how accurate this is? Whether we know them or not. What determines how accurate this sample is?
What grade the surveyor in? A lot of people in what grade or something.
Okay. So his comment was what grade the person doing the survey is in, because he might survey more people around him, more people his age. What major they're in. Okay. Time of day. And this all three of those pieces contribute to the idea of how random of a sample is it, right? Did Seth truly get a random sample? Or is there some what?
Convenience.
Yeah, was it convenience, or did he truly get a random sample? Or were there some pieces of some things that caused some sway there? So now here's the deal. If you got a good sample, this is probably pretty accurate, right? So the idea that the better the random sample you get, the more accurate it will be. What about size? What can we talk about with sample size?
The bigger the size, the more likely to be random.
Okay, so he sampled 20 students. Now, do we have any idea how big this college is? No, definitely probably bigger than 20 students, right? You know, but the bigger the sample, the more accurate of a representation it's going to be. Okay, 20 could be kind of small, really. You know, if we're talking a college, you know, it says local college, so even someplace like IUK, 20 is kind of small. Okay, so the bigger the sample size, the more accurate you're going to see a result there. So we don't necessarily know how accurate this estimate is, because we don't necessarily know how Seth got his results. We don't know how big this college is in reference. But those are the two key points that I would think about: is the larger the sample, the more accurate the estimate will be, and the more random the sample, the more accurate it will be. Okay? So those were the two pieces of information I was going to write down. The larger the sample, the more accurate the estimate will be. And just in general, the better the sample. Okay, the better the sample represents the population, the more accurate the estimate will be. Okay. Again, write as little or as much as you want there. Okay. Start thinking about the next one when you finish writing the previous one. It asks us to use the sample data to estimate the mean distance from home. How are we going to do that? Okay, add them all up, divide by the number of numbers, which in this case is going to be 20. That's the reason I'm hearing a lot of calculators come out. Yeah. Asking us to use the sample to estimate the mean distance from home. Do you guys know what they added up to be?
2017.
So if those numbers summed to be 2017, there were 20 numbers you summed. 2017 divided by 20 was what? 100.85. And that would technically be 100.85 miles. Okay. Is that an accurate representation? Kind of hard to know, isn't it? Again, is 20 enough to really have a good representation? I don't know. Okay. I would definitely say maybe the freshman that lives 800 miles kind of threw things off a little bit. You know. Because I'm not sure I would feel otherwise that the average would be around 100. I feel like it'd be lower, but 800 kind of, throws things off a little bit. Okay, last one on this particular section. Estimate the proportion of seniors to the total population at the college. What are we doing here? Okay, number of seniors divided by the total. How many seniors are we seeing?
3.
Just 3? Oops. Okay, so what's that tell me then? 3 divided by 20. What are other ways to express 3 divided by 20? That is the decimal 1500ths. And it is the percent 15%. Okay. We're going to continue on with this example, but we're going to add Tia's information in. Okay. As you look down at the bottom, okay, we talk about, using multiple samples now. And we're talking about Tia. Tia is contributing to the same project as Seth and has sampled a different group of students. Okay. The proportion of freshmen in her sample is 4/10 or 40%. How can Seth and Tia determine whose result is a better representation of the population?
Who has the most, the closest together? Or has an equal amount of each grade level, so like equal amount of freshmen, equal amount of sophomores, equal amount of juniors, equal amount of seniors. Like roughly.
But do we know that those grades are all equal at the school? Are there the same number of freshmen as there are sophomores, juniors, and seniors?
Yes. I don't think we have for a fact.
You know that for a fact, huh? Okay.
Yeah, I actually wrote this one.
Oh, okay.
We would just put down we don't got enough information.
Okay. So Okay, so if we don't have enough information right now at our fingertips, okay, which I could agree, we don't really know right now, how could Seth and Tia, what could Seth and Tia do? Could what? Combine it to make it 40 people? So then that's just going to change the numbers altogether. Because if we're combining them, now we're looking at what? It's probably going to fall at 35%, I would guess. If it was 30 and 40, I would think that it would. Now you've got 7 out of 40 maybe. Okay. If we don't have enough information, could we look at gathering more information?
We could tell them to do that.
Huh?
I said we could tell them to do that.
Well, because I mean, if you, depending on how you interpret this question, how can Seth and Tia determine whose result is better? Could there be an option of them getting larger samples, gathering more information? Okay, as they gather more information, might their answers become more the same? Kind of like yesterday. As our sample size got larger, you know, we did 5 rolls, then we did 10 rolls, and we did 30 rolls. Did our answers all kind of head towards the same direction? We all landed in that 3 area in this class, right? Okay. And so, the idea of basically looking at more data. Okay, we don't really have enough data right now to know. I would agree. So whether we examine larger sample sizes or even just more samples, okay, take some more samples and in general see where we end up. Okay, so I have something written along those. Tia and Seth can examine more and or larger samples. And I'm going to tag on there at the end to gather more data. Okay, so Tia and Seth can examine more and or larger samples to gather more data. Somehow or another, just saying we don't really quite have the information we need here. Okay. Continuing on talking about Seth and Tia. Everyone in Seth and Tia's class completed the same survey. The histogram shows the results of the 50 total samples of 20 college students each. So now we've moved on from, it was Seth doing this. Then it was Seth and Tia both did this. Now it's everyone in their class did this. So you've got Seth with 20 people, Tia with 20 people, all these different people did this. So what we're looking at here, it's results of 50 samples. So basically we're looking at the fact that 50 different people did this same survey. They each surveyed 20 college students. Okay? Now, things to look at here. What do you recognize about the shape of this graph? It's what?
Proportional.
Proportional? What's the name that we've been talking about lately?
Skewed.
It's not skewed, though, necessarily. And when it's not skewed, what is it? What kind of distribution is it?
Even. Perfect.
The word is not there, is it?
I'm not cheating you.
Normal.
There we go. Normal distribution. Okay. When we start talking, you guys, so we talked about that empirical rule, right? That empirical rule that was the 68, 95, 99.7%. Okay. That was on a normal distribution. As in, you know, we're never going to expect it to be perfect, but the idea of does it follow that shape? Okay. So, and since it does follow that shape, it's going to look like a approximately normal distribution. Now, we talk about the fact that if you go back to our empirical rule of 68, 95, 99.7, okay, most of our responses should fall in 95% of the data, okay? If we think about this, okay, notice, what do we have here? I'm trying to remember how this one works. Okay. If we look at this as a symmetric shape, yes. Okay. And let's see. I believe from 0.1 to 0.35 is where we're going to find 95% of our data. And I think my brain's trying to remember how this works. Okay. If we look at this with the idea of taking off those end pieces, okay? So if we think in terms of, and it's slightly different here because we have an extra bar in the middle, but if we think about, here's our highest, so that represents the idea of the mean. You go out 1, you go out 2, we're looking at the idea that most of the data falls right there. Most of the data falls in that 95%. Now, and think about it, does it make sense? We've got a little tail here, a little tail here, right? So when you've got those little tails, those are going to be the extra total of 5% or 2.5% on each side. So with this idea, majority of the data, and I think the graph proves it, majority of the data falls in that 95%. Now, with this in mind, what is this suggesting? The proportion of freshmen probably falls from where? 0.1 to 0.35. If we backtrack to Seth versus Tia, what's that say about Seth versus Tia? Well, what did Seth come up with for freshmen? Okay. When we talked about Seth's, he was in the 20% range, yes? Okay, or 0.2. What did we come up with for Tia? Or I guess we didn't come up with it, but 0.4, yes? With that in mind, now would you say whose is more accurate?
Getting it set.
Okay. Seth's is more in the range of what his classmates did, right? If you look at the data, the more centralized it is, the more accurate it's going to be. And here you've got lots of different samples. Granted, they're all each 20 students, but people collected this information in a variety of ways. Okay? So, some information. I'm going to write down some information here that we've talked about along the way. We start off with the idea that this is approximately a normal distribution. If it's approximately a normal distribution, most responses fall between 0.1 and 0.35. So reasonably expect the population to be in that range. Most results fall between 0.1, and 0.35. So can expect proportion of freshmen to be in that range. Okay, so far I talked about approximately a normal distribution. Most results fell between 0.1 and 0.35, so can expect proportion of freshmen to be in that range. And circling back to Seth versus Tia, Seth's results are a good representation while Tia's are not. Or Seth's results I will say, better representation than Tia's. I guess it's not exactly 95%, it's just more of an eyeball of where it is. Because as I look at my notes, I didn't actually have 95% on this one. My brain went to 95, but I didn't actually have that in my notes. Okay. Now, continuing on. Each classmate calculates the mean distance home in miles reported by their participants. Seth and Tia create this histogram to investigate the sample statistics. First question. Okay, so right here, these are the results of the 50 different samples from their classmates. Okay, mean distance from home in miles, number of samples. The first question is, how many samples reported an average distance from home between 101 and 125 miles? I agree. Why 6? Yeah. If we look, specifically they want the range from 101 to 125. So that is this bar right here, yes? Okay. 101 to 125, is that going to be that bar right there? How tall does it appear that bar is? It appears 6. Okay, so 6 samples have an average distance of 101 to 125. Okay. And then use the histogram to suggest a reasonable interval to estimate the population parameter. Okay, so this is the samples. When we talk about estimating the population parameter, this is, okay, taking your sample information based on the sample, what would you suggest might be true of the population?
Nobody lives on campus.
I don't think you can say no one lives on campus. Well, okay, wait. Average, they're not talking about, these are students that do live on campus.
Oh.
Okay, so they're talking about, you know, if if you're living on campus, but you're 50 miles from home, like from Sharpsville type thing, from Tipton County. Okay. These are the distances that you would travel to go home for the holidays, the weekends, that type of thing. Okay.
For that case, everybody has to travel to go home.
Where's the majority of the information lie? Okay. We've got our highest bar from 51 to 100, yes. However, there's another tall bar right next to it, yes. Okay. If we think in terms of the normal distribution curve, okay, and think in terms of, okay, where is the bulk of that information? And I would go a little farther out than the 51 to just 100, because again, if we're thinking of this being a normal distribution, which it has that general shape, yes. They're not going to necessarily be perfect, but it has that general shape. If we just pretty much get rid of the tails, what are we looking at here? A lot of data falls between those middle 4 bars. Okay, really a lot in the middle 2 bars, right? I would go out a little bit farther and include a little bit more than that because there's still quite a few people going there. And here's the deal. Do some numbers go higher than this? They do, right? This is an average. Was it Seth's example or that had an 800 in it, right? That's not the average. Okay, that one's a lot higher. Okay, so this is the 95% of our data here. Okay, and again, it's not specific exactly 95%, but it's that idea. Okay, so I would have said that the average distance from home likely is 26 to 125 miles. Okay, and that's still, in thinking, that's still a pretty small range when we can talk about traveling across country or across the ocean or wherever. Okay, so average distance from home likely to fall between 26 and 125 miles. And again, keep in mind, these are already averages, right? These are already averages here. Okay. I think we're finally done talking about Seth and Tia. We get to move on to Gabriella and Alex. So get what you need there, and then start looking down at the next part when we talk about using a simulation. Okay. What we looked at with Seth and Tia, it was them using a sample, them going and physically gathering actual data that we can use to represent the population. Now, not always the easiest option, not always even an option, to go and gather data to represent the population. So we're talking about now the idea of how you could do a simulation. Okay. Gabriella wants proof of Alex's claim that he is a 75% free throw shooter. She observes Alex shoot 50 free throws, of which he makes 30. Gabriella notes his 60% success rate. But Alex points out this is a reasonable result due to the natural variability that happens from sample to sample. Is he correct? Okay. So, lots of different ways we could argue this, obviously. Okay. One option, though, to look at is, and again, I know ideally going out, collecting the information. You know, Gabriella gathered information watching Alex. You know, going out, gathering that information repeatedly, those type of things, that's your ideal. Okay? But we're going to look here at a situation of how we could use a random number generator. Okay? Your calculator can do a random number generator. Excel can do random number generator. Okay? Here on this page, we have a chart. And the question is, how can you use random numbers to investigate Alex's claim? So, what I want to talk about here, don't run out of time, how can these numbers represent Alex's successes versus failures? And this is, what's his claim again? His claim is that he's a 75% free throw shooter, yes? So he claims 75% of the time he's going to make those shots. Then there's going to be that other 25% of the time that he doesn't make those shots, based on his claim. So what do you see here? You've got a chart of numbers, yes? The numbers in this chart are between what and what? Are they between? Okay. Numbers generated should all be numbers between 1 and 100. And I think, how many numbers do we have here? We've got 50 numbers, yes? Okay. So this is a sample size of 50. So this would be 50 shots. Of these 50 shots, how can we indicate which ones are makes and which ones are misses? Based on his claim, 75%. And it's kind of hinted at here if you look at mine, which is in color. Okay. What is it showing you here? It's showing you some of the numbers in, what is that, orange, and some of the numbers in blue. What?
Why can't you say yes, he made it, no, he didn't?
Because if you say yes, he made it, or no, he didn't, that's a 50-50 shot. He's claiming he has more than just a 50-50 shot. He's claiming he has a 75% shot. So the idea here that these numbers in orange are all the numbers below 75.
So what's the number of the letters for top? What do you get?
That is just like if you did this on an Excel spreadsheet. Those are the columns that used in the Excel spreadsheet. Gosh, I can't talk.
So he's saying his first shot, he had a 50% chance of making it, and then the second shot, he had a 90% chance?
No. So this is a random number generator. Okay, random number generator just said, okay, generate me, pick 50 times in a row, pick numbers between 1 and 100. If he has a 75% chance of making it, then I want to, here's the deal. If I just use yes or no, that's a 50-50 shot. Whereas if I use numbers, I'm able to indicate the 75%. Okay, so what we're looking at here is all these numbers that are 1 to 75. If he claims he's a 75% shooter, what are all these numbers 1 to 75 representing?
Yes.
These are his makes.
So
Okay.
Every shot, not like 50 shots, you gotta make 75%.
What'd you say?
It's every shot, not.
Right, so every shot, he claims he's a 75% shooter. So he has 75% chance of making it. What we want to know is we're trying to see, okay, does this random number generator validate that? Okay. And if I had another minute, we'll talk about exactly how this works tomorrow.